Welcome to Key Tech. Please describe this channel if you are interested in today's video. Silicon Valley in the United States is the kingdom of the electronics and computer industries. It is still the center of global high-tech innovation and development. The headquarters of technology giants such as Intel, Apple, Google, Microsoft, Nvidia, and Tesla are gathered here. Because of the earliest research and production of silicon-based semiconductor chips, it was named Silicon Valley. The main reason why Silicon Valley can stand at the forefront of the world's technology should be its openness, which has attracted outstanding talents from all over the world. IC, originally an English abbreviation for Integrated Circuit, has become an abbreviation for Indians and Chinese in Silicon Valley. Because of Indian and Chinese, the acronyms of these two English words are IC. Is this a coincidence? This also reflects an important issue, that is, Silicon Valley has the largest number of immigrants from India and China. Now China can also see that many high-tech companies in Silicon Valley have many executives and core technical personnel who are Chinese and Indian. Although the semiconductor industry originated in the United States, the research and development process has the joint efforts of talents from all over the world, and its development and growth is also the result of the division of labor, cooperation, and joint participation of all parts of the world. However, the United States uses its advantages as a tool of sanctions. Since 2018, measures related to chip restrictions have continued to increase. First, it prevented ASML in the Netherlands from selling EUV lithography machines to China's SMIC, and later imposed a chip ban on Huawei, and then let TSMC stop the foundry. In October last year, the most stringent new export control regulations in history were released, restricting China's development of 14 nanometers and below processors. The global chip industry should be carried out in an orderly manner according to the laws of the market, and each region in the world should take its own responsibilities and play their own roles, so as to achieve a win-win situation. For example, the United States has advanced chip technology, and China has the world's largest semiconductor market. However, in order to maintain its technological hegemony, the United States has added Chinese companies such as Huawei and SMIC to the entity list, and has also implemented a series of chip restrictions. As a result, China showed three trump cards and began to show its strength to the outside world. Because Huawei has achieved global leadership in 5G, the United States has no way to catch up, so it imposed 4 rounds of sanctions on it, focusing on restricting chip procurement. In particular, TSMC stopped high-end chip foundry, causing Huawei's mobile phone business to plummet. There is also SMIC. Since the arrival of Dr. Liang Mengsong, the wafer manufacturing technology has advanced by leaps and bounds. It has completed 5 generations of technology research and development in 3 years, directly breaking through from 28 nanometers to 7 nanometers, and mass production can be achieved only by EUV lithography machines. Originally, SMIC ordered an EUV from ASML in 2018, but it was hindered by the United States and has not yet arrived. In fact, the core problem of implementing chip restrictions against Huawei and SMIC is the lithography machine, which is the biggest shortcoming of China's domestic chip equipment. Today, China is still unable to make high-end processed chips, mainly because of lithography machines. The United States is very aware of this, so it has long been eyeing the lithography machine. EUV was restricted before, but now it wants to expand the restrictions on lithography machines and further restrict EUV shipments. Therefore, Lashan, Japan and the Netherlands reached a certain agreement to jointly restrict. EUV is used below 7 nanometers, and the impact after the restriction is not big, but DUV is used for 7 to 45 nanometers, which is most needed in China now. Once DUV is restricted again, it will indeed have a considerable impact on the development of China's chip industry. Then, China has only 3 ways to go. First, accelerate the purchase of as many DUV lithography machines as possible before the restrictions are officially implemented. Second, accelerate the self-developed domestic lithography machine, such as the 28 nm immersion DUV lithography machine that Shanghai Microelectronics is tackling. Third, the idea is to bypass the lithography machine, which requires the development of other types of chip technologies, such as quantum chips and photonic chips. In fact, China is taking these three roads. Recently, China has shown three trump cards which can explain the problem even more. First of all, Harbin Institute of Technology has made breakthroughs in lithography-related technologies. Recently, Harbin Institute of Technology won the highest award from the Optical Society of China because it broke through the high-speed ultra-precision auroral interferometer, which can be applied to lithography machines with multiple process nodes from 350 nanometers to 28 nanometers. It is reported that the 28 nanometers lithography machine of Shanghai Microelectronics has already used this technology. And according to Harbin Institute of Technology, this technology can also be used in the research and development of 7 nanometers and below node lithography machines, which is the technical basis for the development of higher-level lithography machines. In addition, Harbin Institute of Technology has also made breakthroughs in technologies such as EUV laser light sources and dual workbenches, which will lay the foundation for domestic EUV. Secondly, the first quantum chip production line was unveiled. Quantum chips will be one of the most important development directions after today's electronic chips. China has lagged behind in electronic chips, and it will certainly not fail again in new types of chips. Recently, China's first quantum chip production line was officially unveiled, and the quantum chips it produces will be used in the most advanced Wukong quantum computer. The calculation speed of Wukong is simply beyond imagination, breaking through the calculation limit of electronic chips. More importantly, quantum chips can bypass lithography machines, and the quantum chip industry chain has all achieved independent research and development. Furthermore, the Chinese Academy of Sciences made a breakthrough in photonic chip technology. Photonic chips are also an important part of future chip development. Compared with traditional electronic chips, they are faster, consume less power, and have 1,000 times the performance, but only 1/90,000 power consumption. According to recent news, the Chinese Academy of Sciences has broken through the 3 nanometers photonic chip transistor technology, which will help the development of domestic photonic chips. At the same time, China's first cross-size, multi-material photonic chip production line has been built and put into production in Beijing. Moreover, photonic chips can bypass high-end lithography machines, and domestic ordinary lithography machines can be used, and other equipment is not limited. Recently, Shanghai Jita Semiconductor issued a tender for IFI immersion DUV lithography machine, and Nikon of Japan won the bid. In addition, SMIC previously ordered DUV lithography machines from ASML and paid a deposit in advance. This is the first way to solve lithography machines. The above 3 trump cards show that China is pursuing the second and third roads, which will completely solve the problem. Of course, it will take time. After all, the industrial layout needs to be advanced many years. Today, the 3 trump cards that China has shown are probably not expected by the United States, Japan, and the Netherlands, and joint restrictions will not work. In this regard, some foreign media said, China is trying to use 3 ways to break through the lithography machine.